Hello everyone, welcome back to A4 Analysis. In this episode, we will try to solve some of the practice problems from the book Business Statistics by Ken Black. And here, in particular, we will solve few problems where we want to estimate population proportion and where we want to estimate population variance. So the first problem is for estimating population proportion. Let's check out the problem statement. So we have used the information about each of the following samples to compute the confidence interval to estimate P. P is the probability of success, and the first one is n equals to 44, P hat. Okay, so let me just say it one more time. P is actually the probability of success in population, and when we have P hat, it's actually for probability of success in sample. So we want to compute 90% confidence interval when n is 44, which is the sample size, and P hat is 0.51, which is the probability of success in sample. So this is how it looks like. This is the confidence interval formula for population proportion. So first we have written down all the numbers, and we will need Q hat as well. So if P is the probability of success, Q is the probability of probability of failure, and P hat is the probability of success in sample, and Q hat similarly probability of failure in sample. So for the confidence interval formula, it looks something like this. The lower limit for P is P hat minus Z into root over P hat into Q hat divided by N, and N is also a square root. And the upper limit is P hat plus Z into root over P hat into Q hat by N. Let me repeat this once more. Population proportion confidence interval formula, the lower limit is P hat minus Z into root over P hat into Q hat by N. Upper limit is P hat plus Z into root over P hat into Q hat by N. So this N is small n or sample size. So these are the values we are just directly imputing, and this will be the final result. Again, Z value we have to find out because we already have 90% confidence interval given. So directly we are imputing the Z value as 1.645 for the given confidence interval. Now let's move on to the second problem. The problem statement is as follows. Use the following sample information to calculate the confidence interval to estimate the population proportion. Let X be the number of items in the sample having the characteristic of interest. Now this is a slightly different problem than the first one that we did. So we are given with sample size small n, which is 116. We have X, which is the number of items in the sample having characteristic of interest, as 57, and we have 99% confidence. Now what do we understand from this one? X be the number of items in the sample having the characteristic of interest. This is actually given to find out P hat. So P hat is not directly given, it's given in an indirect way. So if we have sample size as 116, and it is actually telling that 57, for 57 instances we have success or we have true value, means it has the characteristic. So if we have total 116 samples, and out of 116 samples 57 have positive or success, then the probability of success in sample will be 57 by 116. So P hat will be 57 by 116 or 0.49, and Q hat, which is the probability of failure in sample, will be 1 minus P hat, which is 0.51. Now we already have 99% confidence. We can directly impute the z value, and rest of the things are same as before. This is the confidence interval formula. We can just impute all the values and bam, we have the final results. Now let's look at the next problem. Okay, the next problem is a little bit longer. Here we are trying to estimate population variance. Now let's look at the problem statement first. The Universal Music Group is the music industry leader worldwide in sales according to the company website. Suppose a researcher wants to determine what market share the company holds in the city of St. Louis by randomly selecting 1,003 people who purchased a CD last month. In addition, suppose 25.5% of the purchases made by these people were for products manufactured and distributed by Universal Music Group. Two important information we already got, that is, randomly selecting 1,003 people means this must be our sample size. The next information is 25.5% of the purchase made by these people were the products from manufactured and distributed by Universal Music Group. So this is similar to our proportion. This will be our sample proportion because this is our sample size and this is our sample proportion. We already know this. Next, based on this data, construct a 99% confidence interval to estimate the proportion of the CD sales market in St. Louis that is held by Universal Music Group. Number B is, suppose that the survey had been taken with 10,000 people instead of just 1,003. Recompute the confidence interval and compare your results with the first confidence interval. How did they differ? What might you conclude from this sample size and confidence intervals? Now let's put all the numbers together. So of course our sample size is 1,003. P hat will be 25.5%, which is the probability of success in the sample, right? So this comes out to be 0.255 because we are bringing it into fraction, and Q hat will be 1 minus P hat, so 0.745. 99% confidence interval means Z value will be 2.576. Rest other values we are just imputing, and the formula for confidence interval looks fairly simple, same as before. The lower limit will be P hat minus Z into root over P hat into Q hat by N, and the upper limit will be P hat plus root over P hat Q hat by N into Z. So we have got this confidence interval. So P will be lying, or population proportion will be lying somewhere between 0.220 to 0.290 or 0.22 to 29. This is the range. Now if we increase the sample size, we can see that the new confidence interval that we are getting is 0.244 to 0.266. Now one thing which is interesting to see here, we want to know what is the difference and why is this difference. The first of all, the difference is in this part. So P hat remains same as before. The thing that has changed is this component of the formula, because N is changing, so this second component of the formula is changing, and we can see the interval has become narrower. This is because when we are taking larger sample size, the sample mean will come more closer to the population, not sample mean, sample statistic actually will come closer to the population parameter. So that's what is happening. Sample is just a representation of population but in a smaller size, right? So if we keep on increasing the size of the sample, it will look closer and closer to the actual population, and that is the reason we are able to, even with the same confidence interval, we are able to shrink the range, and the population parameter is getting closer and closer not the population parameter, the sample statistic is getting closer and closer to the population parameter. Next problem is this one. For each of the following sample results, construct the requested confidence interval. Assume the data come from normally distributed population. We have n equals to 12, x bar is given, s square is given, and 99% confidence for sigma square. So here we can see that we have all these values, a 99% confidence interval. So what do we need? We need the chi-square value. So for chi-square, we need two things. Just like z-score and t-score, I have created one more video where I have explained how to find chi-square value from the chi-square distribution table. You can go check it out. It's already available in my playlist Study Statistics with Me. So in short, for finding chi-square, we will need two things. One is alpha, which is 1 minus the confidence interval, or 1 minus 0.99 in this case, and here it comes as 0.01. And we will also need anything else? Yes, degrees of freedom is required. Same as t distribution or t table, we need for chi-square distribution as well, we will need to find the degrees of freedom, which is same, sample size minus 1. Here it is 11. So just if you have the degrees of freedom and alpha known to you, you will be easily able to find out the chi-square value. So that's what I'm just imputing it here, and the formula of population variance looks something like this. This is the confidence interval formula. So the lower limit is n minus 1 small s square divided by chi-square of alpha by 2. And the upper limit is n minus 1 into s square divided by chi-square of 1 minus alpha by 2. This is important. So we have to find two chi-square values. One is for alpha by 2 and one is for 1 minus alpha by 2. So once we have to look up the table for 0.005, and once we have to look up for 0.995. So that's what we have did. See here I have written the numbers as well after looking up the table for these values, and after imputing this is how the confidence interval formula looks like for population variance. Now this is the last problem we have come so far. Let's see what is the problem statement. The Interstate Conference of Employment Security Agency says the average work week in the United States is down to only 35 hours, largely because of a rise in part-time workers. Suppose this figure was obtained from a random sample of 20 workers and the standard deviation of the sample was 4.3 hours. Assume hours worked per week are normally distributed in the population. Use the sample information to develop a 98% confidence interval for the population variance of the number of hours worked per week for a worker. What is the point estimate? So let's just scan it quickly. What do we get here? So says the average is 35 hours, and this is not important. 20 workers, this must be the sample size, small n. Standard deviation is 4.3 hours. This is the sample standard deviation, small s square. Not s, yes, sorry, not s square, it is actually s. So standard deviation small s is equal to 4.3. So in our formula we will need s square, which is nothing but our variance. So we just have to take the square of this 4.3, and we will need 98% confidence. So yeah, just putting the values together, n is equals to 20, and then we have a square 18.49, 98% confidence interval, and degrees of freedom, because we are trying to estimate, what are we trying to estimate again? Yes, we are trying to estimate the population variance. So for estimating population variance, we would need chi-square value, right? And for chi-square value, we need two things. One is alpha and the other one is degrees of freedom. Degrees of freedom is sample size minus 1, so 20 minus 1, 19, and alpha is again, we have confidence interval, so 1 minus alpha is 0.02. Now we need two chi-square values. One is corresponding to alpha by 2, comma, degrees of freedom, and the other one is corresponding to 1 minus alpha by 2, as you can see here. So 0.99 in this case, comma, 19 is the degrees of freedom. So these are the two parameters we need for finding chi-square value. So these are the values, and after imputing all these values, we get the final range as 9.707 as the lower limit and 46.025 as the upper limit of the population variance. And what is the point estimate? Point estimate, since we are dealing with, since we are trying to estimate population variance, so our point estimate is the sample variance, which is nothing but 18.449. So that's it for the video today, guys. Hope you guys found this video useful. If you did, please make sure you give it a like and subscribe to my channel, and please let me know in the comments what do you want to see next. So that's it for today, guys. We'll meet again very soon. Bye, guys.